This is sound. Production of sound. There are various pieces of equipment that can create sound. Okay, so for example, you could have a speaker. You could have air flowing over a tube, and as the air flows over, it will create a ripple on the edge, and that can be amplified through the tube. You've got many types of things that all they have to do is they have to vibrate. Okay, because remember, sound is longitudinal, so you just need to move particles back and forth with some sort of diaphragm or some sort of vibration to create sound. So remember, it has compressions and refractions, okay, because it's longitudinal. So these are the particles in their rest position, and then they get compressed. Then they have refractions. Okay, remember, this is high pressure, low pressure. And then you can represent it on a transverse graph. Remembering that crest is the compression, the trough is the refraction. Because sound travels through the use of vibrating particles, there must be a medium present for sound to travel through it. The closer and stronger the particles are held together, the faster the sound can travel. Okay, so there is no sound in space. It is only when there is mediums. Okay, so in air, you've got to vibrate a particle that could be quite far away. While in a piece of wood or something, much closer, easier to make the next one vibrate quicker, and so on. So here's some examples. Speed of sound in air, about 330 meters per second. Speed of sound water, there you go, around about 1,500 meters per second. And some sort of metal, let's say copper, 3,500 meters per second. So there's a big difference. What's an echo? It's just a reflection from a wall. Okay, so if some sort of speaker device creates a sound wave, and then that reflects off a wall, you should be able to hear the reflection. Okay, so it's going to hit the wall, and you'll get a reflection. So there's a delay. Okay, so from the first time you hear the sound here at the start, there'll be a time it takes to get there and back again because it's going at a certain speed. So you can find the speed of sound from this sort of experiment. So let's say we had a wall. We had a device that made a quick little pulse of sound. Okay, so just to say a speaker. That creates a pulse. That's going to travel, hit the wall and reflect, and you can then have a microphone to measure it. Okay, at the same distance. So if we know the distance to the wall, and then we knew how long it took, so we used some sort of timing device like a stopwatch. So if we have got time and distance, we can find velocity. So knowing those things, you could calculate it. So remember now, the key here, we've got a distance from there to there. The actual distance it travels is twice that. Okay? So the sound has to travel first into there, which is d, and then add another d on, so it's actually 2d. Divided by the time, and you get the speed. We can only hear a certain range of frequencies. Dogs and other animals can hear much more than us, but we can typically hear sounds in the range of around about 20 to 20 kilohertz. Okay, so 20 hertz to 20,000 hertz. Dials up to about 60,000, 50,000. We don't need to hear anymore. That's the key. Okay, we only hear what we need to hear. How do we hear? Well, we might look at this in class, but essentially the vibrations of the air particles go in there, move an eardrum, which essentially will move a pivot, okay, and then that creates some sort of pressure changes in your cochlea, okay, and there's little hairs inside that, okay, and as the motion travels through, those hairs change position and send a signal off to your brain. To change the level of loudness, the amplitude must be changed. So what's the amplitude? On a graph, amplitude is the height of the wave. Okay, remember? So it's the height from the mean position to the top. If we're looking at the actual longitudinal wave, remember you've got compressions and refractions. If there is greater loudness, then the compression must be a lot tighter and the refraction much greater. Okay, so there's greater pressure. Pitch is the frequency. Okay, so the quicker the oscillation of the wave, the higher the pitch. So the higher the note, okay, that you hear in music, the higher the pitch or frequency. So if someone's singing really high, you're in a high frequency. We'll look at this in class.